So, last time we had class, or last unit, excuse me, I gave you all out a great big giant packet that was condensed down substantially, so I wasn't running so many copies, blah, blah, blah. If you haven't completed the Math Excel homework, what day is that due? Does anybody know? 28th, tomorrow?
That's by like 11:59.
Yeah, I think it's by 11:59 on the 28th, so you have until tomorrow at midnight to finish that. And don't wait until the end. There were some people, and I can't remember if it was in here or in any other classes, that had some difficulty going through and logging in. I don't know if it's these computers sometimes that act up. Somebody said that they had some difficulty, and then that there was a password. They tried it, that they had the wrong password, and there was another person that came in. I know that one was in, this one was in another class, that they kept getting boxed out over and over again, but they were going into the wrong website. Make sure it's mathexcelforschool.com. But in any case, that's due by the end of the day. The other thing is all of your assignments for this unit, like your homework packet, instead of printing it out for you, I posted it. There was one posting that we did to Google Classroom that has the big homework packet in it. You can find out, and instead of making the questions bounce from page to page, I literally just made a bunch of text boxes, so it says what the numbers to do, and then underneath it are following it is what the actual questions that you have to do. So that needs to be done on separate paper, and you can find what the numbers and stuff are. They're waiting for you. I didn't get, because you guys took the test yesterday, is that right? Okay. So I don't have yours done yet because I did the other two classes, and then I started doing the calculus exam. But we'll say this now because I think that it applies to all of you. After I went through and looked at the first two groupings of tests, particularly the first group, I noticed that the data was very bimodal, which means that there were two sort of lumps that all of you fell in when you look and you spread out the scores. And there was one group that scored, and in the first class, I think that there's 28 kids, and that there were there were 12 that scored. Out of the 28, 12 scored at a 90 or above. And then there was another grouping that was somewhere between a 75 and an 82. And that constituted like the other big bulk of data. There was, some little snowflakes spread out everywhere else. So I started digging in, and this to me was the most telling. So I started looking, and I said, gosh, these scores seem really low for Enriched. And I've done Enriched 10 years. They seem low-ish. And so what I did was, I guess I want to make sure that we're all on the same page, and it's not by any means to scold you, and we'll see why in just one second. Raise your hand here, and you don't have to say anything if you don't feel comfortable. If your four-quarter average from last year was higher than your Regents exam. Did we do this poll already or no? Okay. I want you to take a look around. That to me, if you remember, if you don't, that's fine too. Now, okay, so that's pretty much everybody. I think there might have been one or two. That to me is shocking in and of itself, and you'll see why in a minute. So that means that your four quarters, and they went over the scale on the exam, like how there's a huge, massive bump up. In order to get a 65, you needed to get a 30. A scaled score of 65 is a 39%, okay, on the exam that you took. But then the other end of it is this. Raise your hand if your score for the quarters was, so all of you pretty much were indicating again that your quarter grade was higher than your Regents exam. Raise your hand if your quarter grade was higher by at least 5 points. Okay. Raise your hand if it was higher by 10 points. Anybody that's 15? Now, this to me, and again, I don't want you to misconstrue anything, because this to me is shocking. Shocking. And it's not by any means a judgment, and this is we always get this stuff coming. Well, I didn't do well on the first test, and I don't know if this is the best place, or I feel like or anything. I'm going to tell you right now, selfishly, this is me being selfish, I am so ecstatic that all of you are on my team. And there is not a better, it's almost like if if I were playing fantasy football and I got the first 28 draft picks, I would have chosen you. And I can't tell you again, don't misconstrue it in the least, because I don't care. I'm not overly concerned with where you came from, but it's where you're going that really concerns me. Because I can control where you came from. But the problem is this. Looking at it from my point of view, that indicates that your grades were inflated. And for some of you, by a profound amount, I'm talking staggering. Because to get a 70, to get like a 70 or 75, that means that you knew 50% of the geometry material. 50%. And if your quarter grade is a 90 and you know 50%, that means that there's grade inflation at or around 40%. Which to me is completely insane by huge amounts. And so again, I'm as a numbers person, I study grades all the time. I look to make what's called a correlation, which means if you plug one thing in, it should be almost like the identity function, y equals x. When I plug in your quarter grade, my output should be your Regents grade. That's how you know that you're grading the right stuff. That's why a lot of times, in all honesty, homework is useless to grade. It's perfectly good to do, don't get me wrong, but it's useless to grade because there's a lot of things, it's your practice. If you play a sport, and that's the easiest reference that we have, if you play a sport, there's some people who are all-stars at practice, and then it comes to game day and they choke. They choke. There's days when I go golfing, and I'll sit there and I'll be on the driver. I couldn't play. You would think, sometimes I will sit there, and literally, Mr. Prenzi and I will be on the course. I'll hit a ball, and I'll say, you know what, I'm putting work. I'm going on the PGA Tour. I'll make so much money, it's ridiculous. And then I'll stand over a putt that's, from here to 2 tiles away, and I'll miss it by 6 feet. Like literally, I would have been more accurate if I turned around and went in the other direction. That's how bad it is. Why? Because I choke. We've got to get it through our heads. So this is what I want you to understand. Before we start with anything, number one, you're going to do fabulous at the end of the year. Terrific. Beyond amazing. Beyond, and I can assure you, my lowest grade from the remedial children last year, well, we'll pull it up in a second, but I believe my lowest grade from the remedial section was a 74. The lowest. And that's on an exam that had not the gross egregious curve that you all had previously, but it had around a 10, at most a 10-point curve, not a 29.1 that you all had. So I went through and I did this to show, and so you understand where I'm coming from. Because again, I almost feel like I'm lying to you if I give you a grade that doesn't reflect actually what you know. The other end of it is this. I look at it from my point of view. If I didn't think that you could do it, or I wanted to be more popular than I even am now, I would give all of you hundreds for showing up. Think of it this way. Would your parents think you were all-stars? Sure. Everyone would be completely happy until you took one test that I don't have access to beforehand. You see, if I make the test, I could go through and say, do number 7, and then when I make the test, I'll say, I'll change the numbers from a 5 to a 2 or something like that, and have you do the same thing. That doesn't mean you know anything at all. It means I train you like I would train my little dog to go piddle outside. You're smart, bright people. So I went through and I said this. Here are the averages from, this was my last enriched section. Now, there are 50 on the button, okay? Here's their Regents grade. Here's their 4-quarter average. Here's the difference. The ones in orange mean that they scored higher on the Regents exam. So, on average, the average kid scored 1.25 points higher on the Regents exam than their 4 quarters. We had 7 and 6, but notice, is there, who here again, I think this was it, raise your hand if you scored more than 5 points away from what your quarter average was, nice and high. That happened to 1, 2, 3, 4, 5 kids. 5, less than 10%. And they scored above it. Now here's the other one. Who scored below it? Because you're probably going, oh, there must have been some people that scored below. Absolutely. I had 1, 2, 3, 4, 5 people who scored 1 point below. The most egregious one here was one 9-point person. 1 out of 50, that's 2% of the population. 1 out of 50 scored less than 5 points. And if you're looking to see how many scored within 5 points, that is 44 out of 50. Understand, I know, I'm not going to make any judgments at all, but I'll say this. I know very well that it probably did not feel, raise your hand if you were disappointed in your Regents score. Raise your hand if you felt when you were sitting there taking the exam confused or disappointed, saying, I don't know this, but I have a 95. I can almost guarantee you, and I don't want to make 100% guarantee, but that's the last feeling I want you to have. The last one. So if I wanted to be an all-star, I'd sit here and go, you know what? You know what we're going to sit and do today? We're going to sit and we're going to talk about our feelings. We're going to do some interpretive. How do inverses make you feel? Okay? Let's do an interpretive dance of how they make you feel. Then we're going to do a poster. And then we're going to go through and we'll do a Kahoot. And then we'll go through and I'll give you, are you nuts? I'm prepping you to hopefully have all of you in AP Calculus. Every one of you I want to have. I hope that there's 4 sections and I get every single one of them. And I'll train you to do it now so you don't have to redo it later. Dear Lord, there's got to be something better than what we're doing. And don't misconstrue for 1 second and think that you can't. Get that out of your head now. Absolutely out of your head. I'm telling you, you know what your reward is at the end? When you're looking, and when I'm looking at Regent scores, just the smallest. All right. So now, again, so here's my cutoff, 85 and above. 35 out of 50, which is what percentage, by the way? Thank you. 70% of the students that took it got an 85 or above. And I feel that that was a failure. Personal. I was fully dejected. That only 70% got an 85 or above. To me, that's terrible. If you think I'm going to hold you to higher X, you're absolutely right. I told you 100 times, you're my little tubes of toothpaste. I will squeeze every bit. If there's enough for one more brushing in the corner, I will wring it up as much as I can. I believe in you more than you believe in you. And I can't stand the way some of you talk, which is, oh, this is tough. We'll call you a ambulance. Of course it's tough. I'm preparing you to take a very rigorous exam. You all want to get into good colleges? I'll tell you right now, from talking to people in admissions offices, you know why you have to take the SATs? Because math that's taught in Mississippi and Kansas is probably a little bit easier than the math that's taught in affluent suburbs of Rochester, New York. Their grades are inflated. You need something common. That's why you take a Regents exam. Every student in New York, from the inner cities of Buffalo down to the most affluent suburbs of Long Island, take the exact same test. And if I'm looking at a student who goes through and they go, but you know, this kid, they scored an 87 on the exam, versus some kid from Long Island who got hundreds in every quarter, and then when it came to one standardized test, like the SAT or the ACT or the Regents exams, they do terrible. Who are they giving preference to in admission? Those grades are wholly inflated. It would make you look like an all-star if I gave you hundreds, and everyone would feel great and you wouldn't know a thing. We'd be as smart as floor tiles. I'd rather it be the other way by a mile. And that's what I understand. No offense, I know what I'm doing. By a ton. But the other end of it is you have to go through something. Don't let your life happen to you. Who here wants to go to a college? Okay, terrific. All right, just so we're clear. Because that's what I want from you. I got another one. Wait till you see. And I'm so, as you can tell, I'm a profoundly humble person. I'll show you another one. I was sitting there over this weekend. I got another terrific message from somebody. And I'll show you exactly what they had to say. I even said it. Was it me? Of course. And I'm selfish. Why? Because when the spreadsheet comes out with all your grades on it, your number is immediately next to my name. I want all of my scores to be profoundly high. If I saw a 70 or something like that next to my name, I would be disgusted. I'd be shocked. I'd sit there and go, no. You know what I'll do? I'll come to your house over the summer. That's what I'll do. I'll track you all down. I'll be waiting in your job. I go, what was that? You know how embarrassing that is? You got a 79? Are you crazy? You're very bright people. But you have to get it through your head, because that's the other end of it, is the grade worship. I had somebody that came in and said, well, what can I do for extra credit? Not, can we go over and see what I got wrong? Not, what did I get wrong? Was it the same thing as others? What are my weak points? How can I get better? It's worshiping a number. So maybe what we'll do next quarter for this quarter, I'll just put everyone down for hundreds. And then everyone will get off my back and we can actually focus on getting you to know something. Because it would make it so much easier. Are you going to make attempts and fail? By a ton. It happens. I root for the Dallas Cowboys. I know all about failure. Catastrophic failure. Over and over again. You have to get over it. You have to get over it. And this next year is a chance to hit reset. Every unit is a chance to hit reset. And if you think I think we have 7 or 8 assessments now in already. You're going to have a couple more that get input and graded. But I'm telling you, you have got to be more honest. Focus on the understanding piece. Everything else takes care of itself. And it's so ridiculously easy. So easy. But you've got to go through and want it. And that's, at least I hope, that we're all on the same page. Yeah, you have to be up for 20 minutes. Take a look at what we've got. Brand new unit, big new note packet. There's a blank copy of it on there. For the first thing that we're going to do and review today is this. With radicals, every real number has, every positive real number has 2 square roots. If we go through and take a number and square it, every number has 2 square roots, one positive and one negative. The principle of a root refers to the positive one only. Now, if you go through and you're given the square root of 16, you just go through and input it as positive 4. If you are given a plus or minus, here's what you need to remember. If you have something like this, x squared is equal to 16, this is an equation, there's going to be 2 answers, which means you need to remember plus or minus. If you're given the square root of 16, that's equal to 4. That's one answer, not plus or minus. And I think we discussed this before. You know that the power on the equation, highest power, which is called the degree of the equation, the degree tells you the number of answers you're going to get. Have we discussed that before or no? Okay. That's an easy way to remember. If it's x squared somewhere in there, that's when it's plus or minus, because you need those 2 answers. Now, and by the way, you can't take the square root of a negative number. You can't have a negative radicand yet. It's not going to be a real number. It's going to be an imaginary one. So if I were to evaluate out the square root of 169, AJ, what do you get when you take the square root of 169? What's that equal to? Don't go to the calculator. What times itself gives you 169? Nope. 13. And it's only one value. The next one up, we're going to solve for x. So if that's the case, Riley, what would your first step be? We're going to add the 1 over, and I get x squared is equal to 169. So looking at what's there, how many answers to this will I have, Royce? 2. What would you do next to get your answer?
Square root of
That's the difference between the two. When you solve by taking square roots, it's got to be a plus or a minus, because there was an x squared in the equation. Next one up, what would our next step be? Take a look at number 3, and Philip, what would you do to get an answer?
First I add the 49 to the other side.
So we've got 4x squared is equal to 49. Keep going.
Then I would take the square root.
Not yet. You could, I guess, at this point, but it's not the most linear path to get there. Terrific. So now I've got x squared is going to be equal to 49 over 4. What would we do next from here? Amanda, how many answers am I going to get for this, Amanda? Terrific. So x is going to be equal to plus or minus. For some reason, we can't do this. It's 7 over 2. Take the square root of the numerator and the square root of the denominator. Now, the next one's going to be a little bit dicey. You've got x squared is equal to 50. So the first thing that I go through and do, make sure your squared term is alone, which it is. Sean, L, what would you do next from here?
You take the square root of 50.
Now, the only problem is 50 is not a perfect square, so I take plus or minus radical 50. But I need to break that down because while 50 itself is not a perfect square, it does have a perfect square factor. Hands up, please, if you can tell me the largest perfect square number that goes into 50. What's the largest perfect square number that goes into 50? So I write out x is equal to plus or minus. Now, what did I have to multiply that 25 by so it goes into 50? Hands up, please, if you can tell me that. 2. So now I go through and there's 2 terms in the radicand. We can go through and separate out the multiplication if it's in the radicand. I'm going to take the square root of that, and I'm left with x is equal to plus or minus 5 times the square root of 2. Some of us struggle with what that operation is. That's 2 answers. One's positive 5 root 2, the other one is negative 5 root 2. You could mindlessly go into the calculator and get a decimal approximation, but we only do that on very difficult questions that don't ask for an exact answer. Now, in order to simplify these next ones out, you need to make sure that you know your perfect square factors. And your perfect square numbers, they start at 1 squared is 1, we don't count that, 4, 9, 16, 25, 36, 49, that's 764, 81, 100. Next one up would be 121, that's 11 squared, 144, 169 is 13 squared, 196 is 14 squared, 225 is 15 squared, 256 is 16 squared, and that continues on. All of you are expected to know those and be able to break numbers down without using a calculator. The next thing is this. You also need to recognize that in terms of taking the square root of expressions, now here's the part that gets a little bit awkward. You don't need to know, you don't need to know this, but it could come up, it comes up in calculus. If I take the square root of x squared, it's equal to, now technically, and we'll leave this to the side, technically it's equal to the absolute value of x. If I take an input square and take its square root, I'm left with the absolute value of the x. But in reality, at your level, you would just be expected to list that out as an x. And going forward, that's what we're going to do. But when I have you in calculus in the first day, and I go, what's the square root of x squared? And you tell me x, I'm going to tell you it's wrong. And I'll make sure to mark the date and time that I have it at 9 o'clock today. And we'll go back and find the video, and you'll hear me saying this exact thing. If I ask you to take the square root of x to the 4th, I'm asking myself, what times itself gives me x to the 4th? Hands up, please, if you can answer that. What times itself would give me x to the 4th? Terrific. Now, what you need to know is this. Right here, on top of this little ledge that's hanging out in front, that's called the index of the root. If it's not written in, it's presupposed that it's a square root, which means the index value is 2. What you're really asking yourself is, how many times does 2 go into 4? And the answer would be 2 goes into 4 twice. Is there any remainder? No, it goes in exactly. How about this? What if I asked you to take the square root of x to the 5th? Looking at what's there, your index, you're taking the square root, and you're saying, well, that doesn't quite break down exactly. Ask yourself this. How many times does 2 go into 5? 2. So I have out front, or as a coefficient, x squared. But there's a remainder of 1. So this would be x squared times root x. The remainder stays in the radicand. How many times it goes in goes out front. So if you follow that pattern, these start to get really easy. How about x to the 101st power? Hands up, please, if you can tell me what the square root of x to the 101st power is going to go to. Follow the exact same process that we just did. What do you want to say?
X to the 10th power, and then
Careful, because you're taking square roots. What's your index value? 2. How many times does 2 go into 100? Okay, so I have x to the 50th on the outside. Is there a remainder?
yeah.
And what is the value of the remainder?
X.
Yeah, just an x to the first. Be careful, because the reads will throw something like this at you. What if I give you, here's one that they'll probably say. What about x to the 81st power? A great question that would be. Who can tell me what that's going to simplify down to be? We got 1. No. 2. That's multiple times you've done that?
Yeah. X to the 40th power.
You're not taking the square root of the exponent. You do the numbers, but not the exponent. How many times does 2 go into 81? 40 times with a remainder of 1. Because it goes into 80, not 81. Questions on that? Let's bounce over now. Hands up, please, when you can tell me the answer to number 5. Hands up, please, when you can tell me the answer to number 5. What's the square root of 225 x to the 8th? We got one person? Seriously? No. Grace, what do you want to say?
15 x to the 4th.
How about for number 6? John, what do you think that that's going to be? Now, technically, what should be on the end? An absolute value, but we're not going to be overly concerned with it. Okay? Questions on that? How about for the next one? Well, for 7, I'd sit there and go, here's my original radical. I need to break this down. 12 isn't a perfect square. Who can tell me the biggest perfect square that goes into 12? We got 1, 2 times. So I'm going to break this up to 4 times 3. Now, for some of you, this is a good way to see the breakdown of the radicals, or sorry, the exponents, or the variables. X to the 9th is not a perfect square. X to the 9th is not a perfect square. 9 is, but x to the 9th isn't. I want to break this down into a perfect square, so I write it out as x to the 8th times x. Is y to the 14th a perfect square, or something you can take the square root of without a remainder? Yeah. So I'm going to be left now with this. Because it's an even number, and 2, my index goes into that exponent number. Looking at what's there, there are 5 terms in the radicand. Tommy, what's one thing I can take the square root of that's in the radicand position right now? What do you say? And what's the square root of that? Okay, so we've got a 2 here. Who can tell me what else I can take the square root of that's in the radicand?
X to the 8th.
And that would be?
X to the 4th.
Terrific. And we've got one more. Who can tell me the last thing I can take the square root of?
Y to the 14th.
And what is it?
Y to the 7th.
So now there's coefficients in front, and then there's values still housed in the radicand. In front, I have a 2, an x to the 4th, and a y to the 7th. And in the radicand position, I have a 3 and an x. Questions on that? How about for number 8? How will I want to break down number 8? Sabrina, what do you think?
Well, 200 to 20.
No? Think about your perfect squares. What's the biggest perfect square that goes into 200? Check on your list. No. Mm-hmm. 100 times what? Now, is m to the 8th going to be a perfect square? Is n to the 7th a perfect square? How do I want to break it down? N to the 6th times n, because that's still going to give me what I had originally. Now let's look at what's there. Hands up, please, if you can tell me what your final answer would be. Do this out. Keep going. We got 1. We'll wait for 7 of you. 2, 3, 4, 5, 6. You know? What?
And m to the 4th, and cube, and a radical to n.
The toughest thing for you, in all honesty, and I don't know if it's because they don't emphasize it that much in geo, but square roots are actually the sides of a square with that area. So like if the area of a square is 144, you know its sides are going to have to be what? 12. That's what you're supposed to be doing in geometry. Now, look at the next one. How is this different? Well, now we need to work with perfect cubes. That's asking yourself, by the way, notice, these have an index value not of 2, but of 3. That means what times itself 3 times gives me that. And there's some really cool stuff that starts to happen when you work with odd indices, which are for index values. But 1 cubed is going to give me 1. 2 cubed is not going to give you 6. It's going to give you 8. 3 cubed would be 27. 4 cubed is 64. Hands up, please, if you can tell me what 5 to the 3rd is. Don't go to the calculator. Think your way through it. What's 5 to the 3rd? Terrific. How about 6 to the 3rd? Hands up, please, if you can tell me what 6 to the 3rd is. That's 36 times 6. Really? Really? One person?
Mm-hmm.
216. Seven would be 343, and the pattern continues. That's stuff that you could always generate on the calculator if you would go through and type in 7 to the 3rd, 8 to the 3rd, and so on. You could always make that list. How about this? What is the 3rd root of m to the 3rd going to be? Hands up, please, if you can tell me what the 3rd root of m to the 3rd is. There you go. What times itself 3 times gives me m cubed? That would be m. How about this? What's the 3rd root of m to the 15th going to be? Hands up, please, if you can tell me that. Terrific. Because how many times does the index go into the exponent? No remainder. How about this? What's the 3rd root of m to the 16th going to be? Now, this one's a little bit awkward. Be a risk taker. Apply the pattern that we did before. Who can tell me what they think m to the cube root of m to the 16th is going to be? We've got 1, 2, 3. We're getting there. We can't do everything all the time. Close. And you're going to think that you said it right, but you didn't. That's what you told me. That's what you told me. Do you see the one thing you want to change? Cube root. I heard you say square. If you said cube, I'm sorry.
No.
Put a little tiny 3 up there in the index spot. How about this? What's the cube root of m to the 99th power going to be? Hands up, please, if you can tell me that. We got 1. We're better than this. We're better than this. Look at the index, look at the power. Look at the index and look at the power. What do we say? Amalia? How many times does 3 go into 99? How many times does 3 go into 90? Use your calculator. So how many times does it go into 99? Is there anything left over, or does it go in exactly? Perfect. Now let's bounce over, please. We've got 2 examples to go through and get rid of. How about the first one? Hopefully the number 9 is a walk in the park. Who can tell me what that's going to simplify down to be? Take a look at number 9. Ben, what do you think? What's the cube root of 64?
64 is 4.
Okay. And what about p to the 12th?
4.
Now, I'm going to show you this as well. You will have your calculator with you for some of these types of questions. Looking at what's there, though, let's do this. Go into your calculators, please. And let's do this. Just so you're aware, hit Control and then the caret button. Go through then, please. Open a new document. Control and then the caret button. And that's going to give you an indexable root. So we're going to take the third root of 64 and hit enter. Now, what's the square root of 64? 8. Is the square root and the cube root related to each other? So, and you can use your calculator to help you out. The only time I get frustrated is when we're saying something like, what's the square root of 25, and we don't know that. You need the calculator to go to it. How about for the next one? Now, this one's very interesting. Normally, we would say you can't take the square root of this, and you'd be right. You can't take the square root of negative 27, but you're not asked to. You're asked to take the cube root of it. Who can tell me what the cube root, or what times itself 3 times, would give you the negative 27 you've got in the radicand? So, this goes to a negative 3, and this would be m squared, and n to what power? There we go. Because what times itself, so go with your calculators right now and do that. Type in the cube root of negative 27, and let's see what we get. What did we get? Negative 3. All right. Take a look, please. Which one's going to be tougher? Let's take a look at question number... Okay, take a look at question number 12. I'm going to take the cube root here. This is not a perfect cube. Who can tell me what perfect cube? Use your calculator to help you. Who can tell me what perfect cube goes into negative 81? What perfect cube goes into negative 81? Look at the list. You tell me the biggest one. I've got 1 that can tell me, 2 of you that can tell me. We'll wait for 5. 3 of you, 4. Terrific. Terrific. Now, if you use 27, what would be left over? 27 times what would give you the negative 81? Careful. Negative 3. So what do I, you were close, and I'm not trying to be nitpicky, you got the big idea. Who can tell me what perfect cube we want to use to get negative 81? No? Who's right? Negative 27, because we've got to get that negative taken care of as well. So I'm going to break this up into negative 27 times 3 is m to the 10th, a perfect cube. Who can tell me how I want to break down the m to the 10th? No, you were right. 9 times is n to the 12th, a perfect cube. Okay? So now, What can I take the cube root of that's up there? Hands up, please. What's there that I can take the cube root of? And what do you get? -3. M to the 9th is m cubed, and n to the 12th is n to the 4th. So when I do this, it would be -3 m cubed, n to the 4th, and then the cube root of 3m, is that right? Is that super difficult? No. And if you take that approach, the only thing that gets tough is the variables. Now, this may come up perfect fourths. I don't know them off the top of my head. So, go into your calculator. What's 2 to the 4th? Hands up, please, when you can tell me what 2 to the 4th is. 16. Terrific. Who can tell me, please, that's 2 to the 4th? Go in. What's 3 to the 4th going to give you? Hands up, please, if you can tell me that. Terrific. How about 4 to the 4th? Hands up, please, who's got 4 to the 4th for us? All right. How about 5 to the 4th? Now that continues on and so on. Who can tell me how I would want to break down? Actually, we'll bounce over. Take a look at number 14. I'm going to simplify out this 4th root. How will I want to break down what's in the radicand position? Because 32 is not one of our perfect fourths. But what perfect fourth does it have as a factor? 16 times what? Terrific. Hands up, please, if you can tell me how you want to break down m to the 10th. M to the 10th. How do I want to break that down if I'm taking the 4th root? How would I want to break that down if I'm taking the 4th root? Terrific. M to the 8th times m squared. Is n to the 12th a perfect fourth? Yeah. So now let's take our roots. What's the 4th root of 16 going to give you? Connor? What else can you take the 4th root of? And what do you get? No? M squared, or m to the 2nd. What about the n? So out front, I would have 2 m squared n cubed, and then the 4th root of 2m squared. Now, the last thing that you have to know is this. You aren't allowed to go through and leave a radical in the denominator, ever. Except when you get to calculus or anything past that. So, what we have to recognize is this. I'm allowed to have a radical in the numerator, just not in the denominator. This is a different mindset. Hopefully you understand. If I multiply something by 1, do I change its value? Yes or no? Holy tomato train. If I multiply something by 1, do I change its value? No. So we're going to need to take on some ugly one, like 7 over 7, or 55 over 55, or the square root of 1, or square root of 15, or the square root of 15. Those are all awkward ones, but they're ones nonetheless. What's the smallest perfect square that 5 goes into? What's the smallest perfect square number? Because I'm simplifying with square roots. What's the smallest perfect square that 5 goes into? Nope. It goes into. Which number is the smallest one that 5 multiplies into? 25. So I need my denominator to be root 25. What do I have to multiply the 5 by to make that happen? Hands up, please, if you can tell me. What do I have to multiply the 5 by to get 25? 5. So I'm going to multiply this by, I need to multiply by root 5 in the denominator so I can get root 25. And then I've got to do the same thing here. So going across, this would be root 60 over root 25, except there's a couple of simplifications we can do. What's root 25 equal to? Now, is there a perfect square that goes into 60? I think so. I think so. Can you tell me what perfect square goes into 60? And again, you don't get it by staring at me or not trying. Go back to your perfect square list. What perfect square number goes into 60? And again, if you don't know, if you see the list, you just start dividing them out. Who can tell me what perfect square goes into 60? We got one person, 2,
4,
4. So, and 4 times what?
15,
So what's the square root of 4?
2.
Take a look at the next one. What's the smallest perfect square that 8x multiplies into? Hands up, please, if you can think, and if you can answer. What's the smallest perfect square number that 8x goes into? Not that goes into it, but that it goes into. Yeah, 1, 2, 3 of you. What do you want to say? Now, 64x squared is a answer, but not the smallest one. 16x squared. What do I need to multiply 8x by so it becomes 16x squared?
Yeah.
You're right. So this would be the square root of 2x over square root of 2x. When I multiply across, I'm now left with root 10x over, now, I would say, and normally we'll do it in the beginning, it's root 16x squared. Do any perfect squares go into 10? No. Did we get rid of the radical down below? Absolutely. Questions on this? Yes.
We have to
I'm sorry, why do we what?
have to make 16 squared.
You have to make the number in the denominator a perfect square. It could have worked if you did 8x, because you would have gotten 64x squared, your denominator, but then the numerator would have been something that reduces.
Okay.
What you're trying to get down here is you're asking yourself this: what do I multiply this by such that this number, I can take the square root of it and there's no radical left?
Okay.
Okay? Is there more? How about this next one? This is radical x over radical 2. Who can tell me what I need to multiply this by so the radical is removed from the denominator? Or what's the smallest perfect square that 2 goes into? Got 1, 2 of you, 3. I was hoping for a little bit better turnout. Yeah.
4,
So what do I need to multiply that by to make it happen? What ugly one would I use?
radical 2.
Over. What do I have in the numerator when I multiply across then? Emily? What do we have in the numerator?
You would go.
No. What do you get in the numerator?
Oh.
Yeah, the square root of 2x. You just multiply the radicands. But look at down below. What's root 2 times root 2 going to give you? Square root of 4, which is, can these 2's reduce out? No. Now, where can you find your homework? It's through your, no, there's Math XL homework, but that's a separate assignment. Your homework for tonight, you can find it, go into Google Classroom, the packet's posted. You're going to need to go through and give me a physical write-up of what your homework was from the other day. You're going to have to go through and give me a physical write-up of it. It's posted through Math XL, the packet that's in there. It's posted in Google Classroom. The packet itself is posted. If you need to see it, hang on. Here, guys, is your homework. Oh, wrong thing. Here is your homework packet. If you go through and look. It's waiting for you there. All right? Yep, you do it on loose leaf paper.
What do you mean about this music for?
Let's put it on paper. Okay? Yeah.